Hey Technostuds! In this video, we're going to go over the IP address history. What I found is if you understand the history of IP addressing, then you can better understand where we are at and why subnetting exists and how we can implement subnetting. So let's go over the history of IP addresses. We'll kick this video off by talking about RFCs. RFCs is what defines how IP addresses are and different components of addressing and subnetting. Then what we're going to get into is IPv4 and study IPv4. We'll get into classful addressing. We'll get into subnets and how subnets came along. We'll get into VLSM, CIDR, and Classless. And then we'll get into private addressing and wrap things up talking about IP version 6. There are a lot of different standards out there. There's a lot of protocols out there. Some of them are proprietary, means that they're owned by a company, and that company then creates these rules on how things should operate. But a lot of them are open standards out there that are defined that anybody can access. So how do you figure out what these open standards are that are out there? How are they published? Well, they are published through these RFCs. What will happen is there'll be some sort of need out there. And maybe an individual, maybe an engineer, maybe a company, maybe it's a task force, a committee. Somebody gets together and determines what the standard should be to implement out there and how everything should operate. And then they'll put out one of these RFCs. And the RFC, request for comments, will be put out there with description of exactly what they're trying to solve and how they're trying to solve it and what it is, the standard that everybody should fall into. And then what will happen is these will develop over time, and so a new one will come out and supersede or take over one of the prior ones and make one of the older ones obsolete. So these RFCs are a great wealth of information. It shows a bit of history of where we come from and where we're going. And so these are great when you have certain questions. I find that there's a lot of misinformation out there on the internet, or a little bit misleading information out there on the internet. And so what's really helpful is to go back to these RFCs and read it and find out, is it really true? Because this is the source for a lot of different protocols and a lot of different standards that are out there. So we're going to, throughout this video, we're going to actually reference these RFCs and take a look at what the actual RFCs say. Networks is one of those terms that we kind of throw around there, and it can mean several different things. So let's define, first of all, what a network means when it comes to IP addressing. When we're talking about IP addressing, a network is a local area network or a local set of devices that are connected together. So what you're seeing right here could be considered a network, but from an IP address standpoint, there are lots of networks in here. There is a network over here. This is a network of local computers and devices that are plugged into together, that are directly connected on the same network together. This is a network over here. And I don't want to get too involved into it, but these are networks between these devices right here. So when I say network, these are the local networks there. So largely what we're going to be talking about in this video is talking about how what we did is when we broke apart the IP address into the network portion, that represents this right here. And this is a network. And then each one of these on this network is a host. And so earlier iterations of IP version 4 and how it was constructed really didn't leave a lot of networks out there and had a ton of hosts per network. This caused problems and is the reason why we had to continue to change things, is to increase the number of networks there are, and we didn't need as many hosts on these networks. So keep that in mind as we go along in the next lessons. One thing to understand is that IP addresses have been around for a long time. They've been used to communicate between devices on the network for quite a while. But what we're going to do is we're going to start our journey in 1980 with RFC 760, where an IP address was defined that's very similar to the IP addresses that we see now. Although it was very limiting in its scope and how it could provide, and it was very quickly determined that we are going to grow beyond what RFC 760 addresses. So they needed to do something quickly. So in 1981, they developed this concept of classes. So RFC 791 defines what different classes there are and how to break apart these IP addresses into smaller pieces. And we're going to talk more in depth into this. This is just an overview of the history of IP addresses. So shortly after that, they still saw, well, we still see a need, and these classful addresses don't really break it up all that well. So let's create subnets where you're breaking classful addresses down into subnets. And so that happened in 1985 with RFC 950. Then we've got a little bit of a break. I mean, things were still in development. I've got my next on my timeline here, 1995, but this idea of VLSM and CIDR and a few other concepts, Classless, that actually came before this, came in like 1993. But 1995, RFC 1878 came out defining VLSM. We're going to talk about all of those, but VLSM allows us to break out networks even into some smaller chunks and variable chunks, really. And then we get into, they still have a need. So in 1996, RFC 1918 came out. It wasn't the first RFC to define private addressing, but it's the one that we use today. So this came out in 1996, and we started utilizing heavily into this private addressing. And we'll talk about that as well. Still saw a need. We're still realizing we're going to outgrow this. We need a long-term solution, and that's where IP version 6 came out. So IP version 6 came out in 1998 with RFC 2460. So we will be talking more in depth into this, but this gives you kind of an overview of how we created a standard, realized that we were going to become outdated, and then how to create a new standard to cope with how the growing sensation, the growing needs of these networks that were, like the internet was really taking off, and just the craziness that happened with the amount of networks that we needed to be able to facilitate the number of computers and the number of networks that were growing on these networks. RFC 760 is a good starting point because we do see that this IP address looks very similar to the IP address that we have now. But the difference with this RFC 760, one of the first iterations of IP addresses, is that it defined that the first octet is going to be the network. So this octet right here defines the network. What that means is there's only 8 bits devoted towards a network. So if you only have 8 bits devoted towards a network, that means the max number of networks that you can have is 256. It's 2 to the 8th power is 256 possibilities. So this only allows for 256 networks. That's obviously a problem. Quickly, they realized since this is a problem, let us come up with a solution. That's where RFC 791 came about. The idea behind RFC 791, or classful addresses, is that we start breaking down these IP addresses into classful ranges. And they break it down into a class A, a class B, a class C. We're going to get more in depth into what these classes look like and how they're defined. But just know that what it does is it says we're going to, for a class A, devote this to being a network address, which gives us 128 networks and over 16 million nodes or hosts per network. And then if it's a class B, then it's going to be the first 2 octets, which gives us over 16,000 networks and 65,000 hosts per network. If it's a class C, then you're going to use 3 octets, and that gives us over 2 million networks and or close to 256 hosts per network. So if you add that all up together, we're in the millions from a network standpoint. So this allows us to stretch this out and be able to do a little more with these networks. I have a lot more networks, over 2 million networks out there with this structure, with this classful structure. So we operated a while on this classful addresses. So since we needed more networks, then we came up with subnetting, our RFC 950. So the idea behind subnetting is that you still work within those classful ranges, but you can break them down even further. So a couple problems that this is solving. Number one is we still, with over 2 million networks, we still didn't have enough networks. The networks continued to grow, and the amount of connectivity on the internet and all these networks that we're connecting were still continuing to grow. So we needed more networks. The other thing is that the number of nodes per network, 16 million nodes per network, is just really unreasonable. We didn't need that many nodes. You couldn't have that many nodes on a single network. And so what a subnetting is let's take a class A, for example. Subnetting allows us to still stay somewhat in the confines of subnetting, but allow us to draw a line somewhere in here and say, these are all the network bits now. And these are all of the host bits, which allows us to really get more granular with how many networks we have and how many hosts that we have. So now we're able to break apart and have more networks and less hosts per network, and be able to drastically increase the number of networks that we have. Now, between 1993 and 1995, we had these concepts of VLSM, CIDR, Classless come out in the form of several different RFCs, RFC 1518, 1519, 1817, 1860, 1878. So all of these different ones, some of them were different iterations, some were slightly different concepts, so they didn't take the place of the earlier iteration. But essentially what we can think of is this is doing away with the classful addresses. We still function, even now, we still function to a certain degree within these classful addresses. But the idea is that we do away, for the most part, with these classes that we have and really are able to draw the line wherever we want to create different sized networks. And so the big difference with this, between this and subnetting, is with subnetting, if we had a class A, and so that was the default network right there, but then we would draw the line over here, somewhere over here, that was subnetting, is we draw a single line and then all of the networks had to conform to that same subnet. Whereas variable length subnet mask means that every single network could draw the line in a different spot as long as the networks weren't overlapping. So there's a lot more to it than that, and I understand that that probably doesn't give you the full picture, but we got videos for each one of these steps that's going to go much more in depth to explain how to do each one of these. But this gives you a concept of, okay, what is variable length subnet mask? We can draw that line anywhere to denote what is the network side of this and what is the host side of it. Once again, we still realize, well, we still are lacking some addresses and some networks. We're still growing. We need to adapt to this. And then that's when private addressing came out. And RFC 1597, 1627, 1918, all define aspects. They're all different iterations of this. But the one that you're most concerned with is the current one, which is 1918. You will see that on different exams that are out there and you'll run across it. So if you see RFC 1918, think private addressing. You will need to remember that. All right, so RFC 1918 or private addressing, what it is it allows some overlapping of IP addresses. What that means is up until now, you could never have any overlapping addresses. You could never have two machines out there in the world that had the same IP address. Because what would happen is it would be confusing on which device do I route traffic to. I don't know if they have the same IP address. Well, what this allows is for you to, on your network, have some sort of private address that you use within your network, but is never exposed to the outside world. And it gets translated at some sort of gateway, gets translated into an address that can be used to the outside world. Therefore, if you had hundreds of machines inside your network, maybe you just had a few of these public IP addresses that you could use going out into the world. And so private addressing just allows you to, these ranges right here, it sets aside these ranges for each one of the classes. So here's the class A range, here's the class B range, and class C range. It sets these aside for you to utilize within your private addresses. So if you go to your work network, if you go to your home network and you take a look at your addressing that you have on there, it's probably a private address. And other devices, lots of other devices have that same address out there in the world, but once you go out to the internet, you can't have those private addresses out there on the internet. And so what happens is it translates it to some sort of IP address that your internet service provider gives you, so you can go out there and get resources out on the internet. And just what that looks like here, this is a topology. Maybe you have an internal machine right here, and it's maybe using 10.0.0.5 or 4. It's using the .4, maybe it's talking to .5. So internally, you're just using this 10 range to talk to all devices on there. No overlaps within your network. You don't want the same IP address assigned to two different devices on your network. There are a couple exceptions to that when you're dealing with load balancing, but that is a whole nother topic. But for the most part, really, you really can't have overlapping IP addresses on your network. But then as it goes to the outside world, maybe it picks up a private address or a public address of 52.52.52.41. How about that? So then that's what the rest of the world sees, and they never see your internal address here. There was still this idea, though, that we're going to still run out at some point in time. So ever since then, we've been trying to develop IP version 6 and get IP version 6 rolled out, in which case you have, for IP version 4, you have 10 to the 32nd power. You have 32 bits. So 10 to the 32nd power gives you a little over 4 billion different addresses. So a lot, but we use a lot of those. And there's still a little bit of waste that's out there as well. Then you've got IP version 6, and IP version 6 is 10 to the 128th power. They really said, okay, what can we possibly imagine that we're going to need for the foreseeable future? And let's go way above and beyond that. And you can see the number of IP addresses that we have is so much incredibly larger than what IP version 4 has that I don't even know when you get to that level what that's called at that level. But it is a lot more possibilities, a lot more addresses that you can have out there. So that's IP version 6. So there's the history of IP addresses. So we start out with RFC 760, or at least in our story, we started out with RFC 760, where we have just the first octet defines the network, limiting us only to 256 networks, and we can have millions of nodes on that network, but 256 networks was really limiting. So we developed this classful system, or classes, in 1981 with RFC 791 to break this thing down further, to break it into classes, and we're gonna get more in depth into that, but it breaks it down into classes and what those classes look like, so that way we can get more networks. It's not enough, so we come up with subnets on how we can break that down even further, so we get away to a certain degree from that classes. And in 1995, with RFC 1878, VLSM comes out and really starts getting used. That allows us to really choose what subnet we have and get rid of that classful system pretty much altogether. And then we get into private addressing, where we are allowed some overlap between our private addressing of different networks, as long as once you get out onto the network, on the internet, to the rest of the world, that you have some sort of public address that you go out to the rest of the world with. And then you have IP version 6, which is really the future and really where we're going to, because it gives us so much more addresses. Just a quick note, this is really how our course outline is scheduled as well. We will be talking about IP addressing in this module, and that covers these first two iterations, really the classes. We're going to talk quite a bit about classes in here. And then we will get into subnetting. So subnetting is the core of this course. We're going to spend the majority of our time right here in subnets. And so expect us to spend some time in this realm right here. Then we get into VLSM. VLSM really is just subnetting. It's just another degree of subnetting. So we're going to get into VLSM and what VLSM is. We will be talking about private addresses. We're just not going to have a whole module on private addresses. And then the last couple modules of this course is going to cover hex and IP version 6, which really has to do just with IP version 6. So we'll talk about IP version 6. Subnetting is much more simple, so we're not going to really dwell on that area too much. Like I say, most of the time that we're going to spend in this course is on subnets, but this is the layout of this course.